Yes, students, let me take a analysis of your work completion. Total, how many assignments are given to you? 3 assignments, right? Waiting for replies. Yes, good. Now, one by one, I declare the analysis. The first assignment, which was given on 18th of June, it is a very good thing that all have submitted. 2 students may be late to submit, but all have submitted. About second assignment, again, all have submitted. Here also 2 students are late, but these 2 students are different than the previous. And third assignment also, all have submitted. Now I like to ask you, here what happens in every assignment, 2 students and last time only 1 student are late to submit. What shall I do? Those who have submitted late, should I decrease in the sense 0 marks should I give, or should I give the marks to them? I want to know your reviews. Only few students are there, only 2 students are there in each assignment, or 1 student is in assignment who has not submitted in time. So problems do remain. So I want to know your views. If you say 0 marks to them, I'll give 0 marks to them. Their submission is to consider for marks or not? That is my question. Please answer. Okay, considered, but with less marks. Poonam is saying less marks to be what given. Okay. Further answers? With less marks. Okay. Miss punishment should be there for the late submission. It is your view. Okay, I have to accept your view. Now I want to know from you, less marks means how many less marks? 3 marks, 5 marks, 7 marks. Out of 10 I am considering. Out of 10, how many less marks should I give? I agree. Majority is that I should give the less marks to the late submitter. So how many less? Poonam is saying 2 marks. Yes. Swapnal is saying 2 marks. Amisha saying 2 marks. Chetan is saying 5 marks. Alia saying 2 marks. Yes, further replies 2 marks. Rupashi is saying 2 marks. Muskan replies 2 marks. Yes, 2 marks. Neha 2 marks. Ganesh also saying 2 marks. Okay, students. So those who have submitted late, they will get the 2 marks less. It doesn't mean that you have to submit always less. If that remains in continuation, no, then I can not give the marks. But I will inform you in time, and then I will work accordingly. So I'll check your assignments today, and you will get the marks. About yesterday's lecture, today I'll prepare that proper video and I'll submit. By the way, today's video also will be published today only. So yesterday's lecture, its assignment will be there, and today's lecture, its assignment. So 2 assignments one time only I am giving. So 1 more day extra, day after tomorrow. Up to that you have to submit. That much time I will give it to you. Is it clear to everyone? Okay, good. Yesterday I had a discussion about the various standards, various standard chemicals, means primary standard, secondary standard, what is the importance of the standard, and practically how we maintain the standard or how we prepare the various standards, right from the example of the market to the preparation of solutions I discuss. I want to know the answer from you. There is one acid, solid in nature, and we use that acid for standard solution preparation, or we use it to standardize NaOH or any basic compound. So what is the name of that acid, which is a standard acid, which is a primary standard? Yes, Alia, brilliant answer. I want others answer also. Only one answer, not fair. Answers at least. Yes, Ganesh. Okay, succinic acid. Good. For acidic compound, for example, HCl, which is not the standard, but if I have to standardize it, standardization means knowing its exact concentration, then I can use one basic compound. Which is that basic compound? Yes, sodium carbonate. Okay, means so far now you got the importance that standardization is necessary. In the next topic, we are going to discuss the few calculations. So yesterday I noted that your basic about the calculations of various solutions or these chemical calculations which you frequently need to use in the industry is horribly suffered or is terrible. It is to improve students. So from next lecture, I will work on that. But you also have to work. You also have to practice. See, only knowing, only memorization is a one part of the study. It's a very low level study. If you go on applying, yesterday what happened? I asked you 10 molar solution. From 10 molar solution, if I have to prepare the 2 molar solution, means concentration is decreasing. How many times I have to dilute? A simple question was asked. Then I need to spend several minutes to make that concept clear of the dilution and how to find the number of times by which we need to dilute a particular solution. Their practice is necessary. You can do, you have that much ability, but what happened? You never exposed yourself to attempt such problems. You never thought about that. Actually, that is a need, that is a practicability. So now onwards, be very wise. You have to apply the concepts. So yesterday's discussion, whatever I did, is it clear to you? Those who were absent, they will get the video, so they can go through that. So the attendance you can give by seeing the video. Yes. Now today I am discussing the points. These different types of the standards or the reference materials that we use in the industry, or different kinds of reagents, that only I am informing to you. So yesterday's point was there is a need of one kind of reference. By referring that, you can work and the additional things can be done. Means one point or one dialogue or one logic I told yesterday, that's from 10 molar to 2 molar, how to prepare how to prepare the solution. Then you applied that logic, that you accepted that logic as a reference, and you applied that logic in, and you have answered the various questions. Further also if question asked, then also you could able to answer, because now reference is clear to you. Likewise, in chemistry, some references are necessary. If it is a standard, and from that the other thing can be determined, other thing can be analyzed, other thing can be understood. So reference is a need. Reference material, that was a point of what discussion. Now this reference material means can be we can find, means basically we can find the concentration, or we can get a compound which is of the exact concentration. For example, succinic acid that you answered today also, yesterday also you answered, or sodium carbonate. These are the primary standards. Potassium dichromate, primary standards. So few chemicals are there, those are primary standards. When can we say those are the primary standards in analytical chemistry? Last year you have studied that. Yes, when can we say that compound is a primary standard? Can anybody answer? I said HCl cannot be primary standard. NaOH cannot be primary standard. I won't reply from you. That succinic acid is a primary standard, but NaOH is not. Why? What is the need? What is the requirement that primary standard should fulfill? Then we can say it is a primary standard. So the concentration is known. Okay, solution. Concentration remains for solutions, Swapnali. Okay, means partly your answer is correct. Poonam is saying fixed and not very concentration. Yes, partly Poonam, you are right. So what Swapnali said, that only you are saying. Yes, Alia given the correct answer. Purity, that compound remains pure. Other entities doesn't include in that. And that compound doesn't catch moisture, or it is not hygroscopic. Any contamination, water also is a contamination. Water also is an impurity in the succinic acid. So it should be pure. So from pure compound, we can prepare solution, and that solution, Dipali, Swapnali, or Poonam, that you are Swapnali and Poonam, you are answering, no? That solution is a standard solution. Solution can be standard and compound can be standard. My question was regarding standard compound, standard reference. So that reference, succinic acid, sodium carbonate, can be a reference, and with that, that's a primary reference. With that, we can prepare the solution. That's a standard solution. So Swapnali and Poonam, the concept here, the compound should be pure. It is an essential condition for that. Okay, good. Once we prepare primary standard, what is the use of the primary standard? What can we do? From primary standard, we can prepare what? We can work for what? From primary. After primary, what is the second word? After completion of your primary education, what you did? Yes, Swapnali, right. Yes, I'm waiting for other answers also. Yes, Alia, right. Further, one more answer. Yes, Muskan, Kartika, right. Secondary. So from primary, we can prepare secondary standard. So from market, we said, no, that you can prepare. Ismail has prepared yesterday a 250 gram That's the example that it given. That's a weight. It is a secondary standard. From that, other weighing and other standard can be what prepared. That's different. So from primary, a secondary standard can be prepared, or secondary standard can be learned. So with reference to primary only, we are getting the secondary. It is a relative. It is a comparative. Secondary standard you can prepare. So what I told to you, reference materials, first is primary reference material, primary standard. Second is secondary reference material or secondary reference standard. The third references that we use, certified reference materials. Means what kind of different materials we use? Broadly primary, secondary, but certified reference materials, those we use. Means in industry, somebody has given the certification. That certification should be authenticate. That certification should be what? Proper. Then we can what say? That's called a reference material. We can work, we can execute, or we can use it as what the reference material. It should be what? Certified. Means what? In pH meter, there remains a standard solution. That's a buffer solutions that we use. So that buffer tablets, which they remain certified, their pH, if you dissolve that tablet in 100 cubic centimeter of distilled water, then pH will be 4 or plus or minus. Likewise, the variations also they do not provide. That is what certification. Even if you work in the laboratory in future in industry, then whatever the analysis you are doing, with that you are getting what the certification. You are going to give the certification. Your work will help to prepare the certification. Your work will help to estimate that. So it can be work as what the certified standard. One more example that I give it to you. In our laboratory, different burettes are there. Different burettes are there. And we also can calibrate those burettes. But suppose our college decides to calibrate that burettes from industry, from standard laboratory. Then every burette sending every burette for calibration is not easy. Then what can we do? From a industry, we can get one burette standardized or one pipette standardized. And with reference to that, other burettes and pipette we can, what at our level we can standardize. But somewhere reference is necessary. That reference should be certified reference. So that industry is going to give the certificate, this burette accuracy or pipette accuracy 10 plus or minus something, or actually its pipettation is 9.8. So we'll consider it as a reference, and with the help of that, the other glassware we can calibrate. If you know the conductivity meter, then there remains an internal cell. That company has going to give the certificate. It's a conductance is 1 millimoles plus or minus that some error. That also they do what mention. And therefore, we can what calibrate. We can find out the conductance of the various other solutions. So third standard is certified standard material, that after work, some industries or laboratories who have that recognition can what provide. Yes, is that third reference material clear? Certified reference material. Okay, good. Now fourth standard, that's what the reference material. Those reference material directly we want to take. The certified reference material is one aspect, and here I am talking about what the simple reference material. And that certified reference material, from that you can prepare the reference material. I repeat, certified reference material from economic point of view is not every time affordable. So what can we do? We'll get one certificate, one certified standard, and from that we can prepare the other. As like yesterday I told 250 gram weight, from that other 250 gram. Such how many 250 gram weights can be prepared? Several number of weights can be prepared. But we can't say that whatever you have prepared is a certified reference. It is just a reference. That's from one reference we can prepare what the other reference. Likewise, we can what continue. So other references can be prepared. So those references are used many times in biological laboratories. In chemical laboratories also such references are used. From succinic acid you will determine the concentration of NaOH, and that NaOH, whatever is there for little duration you can use, and from that other solutions concentration you can determine. So we can, so with the help of succinic acid, we can determine the concentration of base, that's NaOH. From NaOH, we can determine the concentration of what? HCl. So various samples of HCls and their concentrations we can determine if we know some reference material. That reference material is a NaOH solution, but that is not a primary standard. That is what from other standard we have prepared. As like you can understand, likewise one certified reference material is like a primary standard for us. From that we can prepare the other references. So the fourth standard that I talk, that is what the reference standard. First one primary, second one secondary, third one certified reference standard, and fourth one only reference standard or the reference material. Now I'm talking about the different kinds of the grades of laboratory reagents. Before that, is the point of that's a reference or standard clear to you? How many standards are there? Yes, right, 4. The first one primary, second one secondary, third one I want answer. Third one, yes, certified, right, and fourth one only reference standard. Yes. Now I am coming to the grades of laboratory reagents. Different kinds of reagents are used. The first type of reagent we say as AR. AR means, listen carefully, first type of the reagent is AR, analytical reagent, and this is mainly used for analytical purposes and in research laboratories. As perfectness of that the reagent, purity of the reagent plays a very vital role, and such reagent which are with the many times remains with a certified guarantee of what that concentration of the solution or whatever the assay is there. But always solution will not be there, no? Reagent can be what? Different chemical means we can say as what the reagent. So a reagent, a type I am discussing is an analytical reagent, and this analytical reagent is used for analytical purpose analysis, and in research laboratory considerable purity remains for that reagent. Second type of reagent is laboratory reagent. It also remains pure, but compared to analytical reagent, the purity remains less. So purified organic and inorganic chemicals having reliable accuracy in the routine of laboratory analysis, because every laboratory needs a different kind of the accuracy in the reagent, different kinds of the purity, so remains pure, but the purity extent can vary. In our laboratory for working the plus or minus 1%, but if you have to research plus or minus 0.01%, so that much acceptance for the research level. Here it is allowed 1% also. It will do. It is not going to make that much amount of the difference. So such reagents are called as the laboratory reagents. So first type of reagent is AR, analytical reagent. Second kind of the reagent is LR. Third kind of reagent is guaranteed reagent. It is the ideal quality for laboratory purposes. Batch to batch reproducibility is specially controlled to guarantee consistent analytical results. The grade is equivalent to analytical grade, reagent grade. The nomenclatures of the few manufacturers, how it can be done, that we can see later on. But there remains the guaranteed reagents, means different brands. That different brands we say, okay, that brand means has that much quality, that much accuracy will be there. But every brand also prepares analytical reagents separately as per the need of the research. And here I am talking about the guaranteed reagent, means while purchasing of goods from the market, a guarantee of the product, guarantee of the material we ask for, we demand for, we concern for. Likewise here a guaranteed reagent means they provide the guarantee, reproducibility, for how many times you can use, or how long you can use that what the reagents without the change. So that guarantee also they want the provide there. Means it is nearly analytical grade reagent, but the separate terminology is used there. That is what the guaranteed reagent. Now that guaranteed reagent for different techniques, different kinds of the reagents are used. For example, HPLC. Yes, anybody knows the long form of HPLC? HPLC, long form of HPLC is one kind of instrument. This year you are studying, it's working in analytical chemistry only. Yes, if you don't know, say don't know. Okay, good. High performance liquid chromatography. Okay, that's a yes, yes. Right, Amisha. Right, Ganesh. Brilliant. So for HPLC, a separate category of the reagent is necessary. So whatever I said of guaranteed reagents, so guaranteed reagents for HPLC, that those can be used. And there remain some different standards. For example, ACS, American Chemical Society, as per their standard, that reagent is there. So HPLC level reagent. So AR level reagent, I told to you, AR type of reagent, LR type of reagent, GR means guaranteed reagent, and in the guaranteed reagent you will find what the various types of what the reagents. There HPLC category kind of what the reagent, and that HPLC kind of the reagent for that certification may also necessary. Some standards are to follow. So ACS means American Chemical Society, their standard. With the help of that, reagents are prepared, or that reagent norms are what followed. So prescription or that explanation also is what necessary on that the reagent. And that high quality of the reagent, that we say reagent grade, AR grade, guaranteed grade, those also should follow what the ACS norms means. University that we are considering, let we follow the ACS norms. ACS means American Chemical Society norms. Now for pharmacopoeia, means in pharmacy, because several pharmaceutical industries are there, for that there remains a separate standards. And for they follow which standards? They follow USP, or they follow what the United States Pharmacopoeia standards. Means pharmaceutical industry, for them a separate kind of the standards. We are talking about terminologies. We are talking about reagents. Different standards are there. Different methods are there. Out of that, which somewhere universally to be accepted. Therefore, what we are following ACS method. And in case of the pharmaceutical industry, they are following. They are following, or they follow, or even in India also, we follow USP method. Means it depends, auditor or that industry. We discuss now quality assessment, so quality control. So what quality control unit had decided which standards to follow, which norms are to follow. Accordingly, you need to follow those. But you should know the term. Therefore, I told to you, and that term is USP, United States Pharmacopoeia, and their acceptance. Especially, it is for what? Food, drug. That means if any tablet or if any medicine is following that grade, is as per that grade, its cost also what the changes, because different countries are with different policies, and if all the policies are to be followed, then accordingly grade of the product will be what the different one. And we are talking about the grades. We are talking the different types of what the reagents. So USP is a one kind of the grade. HPLC is a one kind of grade. ACS is a one kind of grade. It's a one kind of standard. So now what I told to you, USP, United States Pharmacopoeia, their standard. Other standard or other comparison for the reagents we do by the NF. This also reagent remains of the sufficient purity, or this product also remains of sufficient purity to meet or exceed requirements of the national formulary. Means national level, some standard remains. So if those are followed, then short form for that is NF grade of the reagent. HPLC is a one grade. USP is a other grade. NF is a this other grade. Okay. Further, Purified means compound originally or production remains somewhat impure, but we are not purifying that. An example, if I have to give a traditional salt which is remains in market, its color doesn't remain perfectly white. It remains somewhat dirty, or it remains somewhat reddish or blackish or grayish. But if you see the branded salt, perfect white it remains. So what has happened there? It is purified. I'm not saying that salt that is purified. There are the different ways by which they can get the salt. Uh, s- Sodium chloride is the byproduct of many industry. So it remains what the white. Or last year, sorry, FY at FY, you might have performed crystallization experiment. Different types of the compounds were given to you. Acetanilide was given, or salicylic acid was given. Different organic solids were given. What were you doing? You were recrystallizing, means you are purifying them. So by purification, purified grade. So that compound is what the purified further, and that can be avoided. That's a it may not be perfectly pure enough, but somewhere that purification technique is followed. Therefore, it is said purified grade reagent. Further, technical reagent means it's a that reagent or chemical remains of good quality grade, which can be used for commercial and industrial purposes, but sufficiently not pure to be offered for food or drug or medical use. Means in our college, different chemicals are there. Those chemicals, few chemicals we can use in the food. For example, vinegar. Vinegar we use in the food, acetic acid. But that acetic acid is of the food grade, food quality. But acetic acid, I'm not saying solution prepared. A glacial acetic acid present in the laboratory, it is not for the food purpose, drug preparation purpose, medicine preparation purpose. It is just for the laboratory use, technical use. It is not for the food, because for food and all, toxicity should not be there. Suppose if that acetic acid is the byproduct of one company, and that's one industry, and in that industry produces some toxic chemical, toxic compound as a main product, then chances are there stresses will be there. So that will affect a lot on the physiology, that will affect a lot, or that will work as what the poison. And therefore those chemicals remains of the good quality, not too much exact pure, but technical point of view, laboratory work point of view, maybe what the allowed, the grading that we say is allowed. Means plastic, if we say the plastic for water keeping remains of one grade. In every plastic we can't keep the water and drink that. Chances are there, toxicity will be there. And therefore what I'm saying, different types of the reagents, the reagent may be pure, but chances are there it is not good or not healthy. So for food preparation, for drug preparation, it cannot be used. It may be the purified, or it may be what the technical. So for the food quality, different kinds of the method is to follow for the preparation. The other one, OR. OR means organic reagents that are suitable for research applications. There remains a trademark, as like last time I saw like a trademark. So for research purpose, there remains a trademark. Those remains purified. Those defines chemicals of good quality where there are no official standards. This grade is usually limited to organic chemicals. Means organic reagent OR is a grade. Those cannot miss, whatever I discussed, standardization, primary, secondary. So it is not possible for the all organic reagents. This reagent or that entity is of that quality. So for that they mention it is an OR reagent. That's all. And OR for organic reagent, many organic compounds only remains, and for that OR quality. This is one kind of grading, different terms, but there remains a certification. There remains a trademark. Other general AR or USP, a line of chemical manufactured under GMP or under the requirements, that's an industry under the requirements of the USP, United States Pharmacopoeia, or say European Pharmacopoeia or British Pharmacopoeia. Likewise, different pharmacopoeias remains, but they also remain with a trademark. The name for the trademark is MBI trademark. So USP is a one of the general AR. AR is an analytical reagent, good quality reagent. But which standards, which norms, which policies are followed? United States policies, then you can say USP. If European countries policies are followed, then you can say it is what the EP. If British rules are followed, policies are followed, you can say it has what the BP. So likewise, different labels are there. General AR. At the beginning, only USP was said. Now I am saying that is what the general AR means. USP comes under what? General AR also. There remains a trademark. Which trademark? MBI trademark. Other FCC means products that meet the requirements of the Food Chemical Codex. FCC means Food Chemical Codex. So for food industry, what are the norms set by FCC? If are followed, then we can use that in the food industry. Otherwise, we are not allowed to use. So FCC is one kind of grade of the reagent. Other CP is a terminology. AR is also chemically pure, but CP means what? Chemically pure. This product's purity suitable for use in general applications. So chemically pure, not necessarily always recommended for the food or drugs preparation. Will not get the codex or the certification of FCC. So that we are saying as a chemically pure. Chemistry point of view, okay. Means tap water or distilled water, whatever you take. So that distilled water, chemically it is pure. But we are not asking you to drink that distilled water, because any other contamination to little extent, and which contamination that we do not know, therefore we are not allowing that. So that distilled water is a chemically pure water. These are the different types. Let me revise it. At the beginning, I told you reagent. And that the first reagent is what? The AR. It is considerably pure reagent. It is used for the research purposes, high grade, high quality research purposes. Second is LR, laboratory reagent. It also remains the pure one, but relatively less pure. For our regular laboratory, depending upon which laboratory, means if you are working in the research laboratory, different kinds of the grade necessary. If you are working in the regular for the understanding purpose, different kinds of the grades of the chemicals are necessary. If you are working for the just simple demonstration point of view, then different kinds of the grade is necessary. So grading I am talking about. So AR, then the LR, and third is the guaranteed reagent, GR. Means there remains a certification. What's the difference in the AR and the GR? For GR, there remains a certification. AR is used for the pure compounds. The GR can be used for the any other reagents. Means from one compound, if other compound is prepared, so that compound can be work as what? The general reagent. So regarding that, the certification can be done. And with that certification, if it is suitable, then we can what use. Means if you go to purchase a cashews, then cashews remains of different grade, A grade, B grade, C grade, as per your. But that C grade, guaranteed C grade, B grade, guaranteed B grade, A grade, guaranteed B grade classification, but in that the guarantee. So that is considered in what? The GR. So these are the main three categories. But later on, if we see that further additional grades for what the guarantee point of view, guarantee as per US norms, guarantee as per European norms, guarantee as per national norms, guarantee as per Britain norms. So there's guarantee different types of the grades remain, different types of the reagents remain, different terms come. In that I told you the first term HPLC. So that industrial, it is a very sensitive method of the analysis. For that method, that much purity is necessary. So HPLC level, HPLC grade, pure chemical. So HPLC as a term is used. Other ACS. Yes, what's the long form of ACS? American, help me. Right, Ganesh, American Chemical Society. Other reagent grade. It's a general name given, reagent grade. It also remains what? The pure, but labeling point of view, the reagent grade it is, depending upon the need of the laboratory. Next one, USP. What's the long form of USP? It is related to pharmaceutical industry now. In drugs, you will study that pharmacopoeia concept, you will study in the drugs. For timing, remember, USP means, yes, United States Pharmacopoeia. Pharmacopoeia. Yes, Rupashri. Pharmacopoeia. So they are with their standard. So that labeling remains. That's a USP grade. Other NF grade. This is applicable for what? Production also. Reagent and plus for the production also. NF. It is national formularity. As per national yes, Ganesh. As per national formulation. That's a type remains. Next one, purified. Whatever the reagent is there, that's a purified. Or one process is going on, you have manufactured that, produced that, synthesized that, and you have purified that. So that remains a purified. So labeling point of view, it is what the purified product, purified reagent. But quality point of view, it will not meet of the AR quality, which is high level quality necessary. Whatever the production took place, and there following norms, only what you did, you purified by means of the water. Other chemicals may not be used. So from one sense point of view, it is what purified means. At SY level it was there, but you might have not done last year. You can produce one organic compound and you can what purify that. So that reagent remains at purified level. Same reagent, same compound may be available in our laboratory, but that is purchased from the market. So its purity and the compound you have purified, its purity may what differ. So what can we say? That's a LR level reagent. In laboratory, whatever we are getting that reagent, no, that's a LR level reagent. And the reagent that you have prepared is the purified reagent. Example that I give it to you: salicylic acid. From that we can prepare the 5-nitrosalicylic acid derivative. That nitro derivative of salicylic acid you can prepare and you can purify that. So that's a purified reagent. And if you purchase in the market, that's a LR reagents. So there's a different grading. Next one, technical reagent. For the laboratory purpose, we can use that the reagent. General grade remains for that technical reagent from purity point of view. Not too much pure, but it can't be used for food and drug industry. Next type I discuss OR. What's the long form of OR? Good. Amisha, Alia, brilliant, perfect answer and fast answer. Muskan, Ganesh, Swapnali, right? It is an organic reagent. So few organic reagents are there. They are labeled as organic reagents, and with the help of that only comparison we can do over there. OR level that we can say. And next, general AR, general analytical reagent, but it is related to pharmaceutical industry. So USP comes under the general AR. Other than USP, what are the other pharmacopoeias I told to you? Short forms? Yes, Alia. EP means European Pharmacopoeia. Yes, Alisha. PHEUR. PHEUR means what? That it means EP only. EP only. That's Amisha. PHEUR means Pharmacopoeia of Europe, or EP, European Pharmacopoeia. Yes, right. Next, yes, British Pharmacopoeia. That's a BP. Like the different terms we can use. Next one, FCC. What's the long form FCC? Which codex? Food Chemical Codex. Yes, for food industry, different kinds of the norms to be what followed. FCC. Yes. And now last kinds of the type, this reagent, CP. CP means what? Yes, chemically pure. Chemically pure. Yes. These are the different reagents. If you have the book of Himalaya publication, you will get that the content easily. If not, then I'll prepare the PDF of that and I'll submit. I'll do that work. I'll submit that in the material. So you can go through that the material and can prepare the notes. So what you have to do, yesterday's notes and today's notes, you have to prepare up to what? Day after tomorrow. Means up to Thursday. So whatever I discussed yesterday, are the points clear? So next point is the chemical calculation that I do later on. Now I'm asking, do you have any question? Okay, all are answering. Good. 17 students are present. You don't have question. So shall I stop now? Yes, students. So I'm going to stop. I request you to quit now. Lecture is over.